Today we are going to study about reducing reagents. The very first reagent that we are going to discuss is sodium borohydride. That is NaBH4. So NaBH4 is prepared by reaction of methyl borate with sodium hydride at a high temperature around 250 degrees Celsius. NaBH4 is formed along with sodium salt of methanol. If we talk about uses, our NaBH4 is a mild reducing agent. And if we compare it with lithium aluminium hydride, which is another reducing agent, it is milder than lithium aluminium hydride. Generally used in the solvent ethanol and isopropanol. And it is used mainly for the reduction of aldehyde, ketone, acid chloride. And it doesn't attack other functional group such as acids, amides, esters and nitro compounds. So acids, amides, esters and nitro compounds are neutral to sodium borohydride. So it only reduces aldehyde, ketone and acid chloride, and there is no effect on acid, amides, esters and nitro compounds. Let's see some reactions. This is acetylacetone. Acetylacetone on treating with sodium borohydride, since it's a ketonic functional group, two ketonic functional groups are present here, they will be reduced, and on reduction we get a alcoholic group. So this will be the product. The name is 2,4-pentane diol. Similarly, if we look at proton aldehyde have a conjugated alkene functional group, proton aldehyde. This is our proton aldehyde. This compound on reacting with NaBH4, again there is no effect on the double bond of alkene functional group, but the aldehyde will get converted to alcohol. So this will be the product and the name will be Docile alcohol. Let's take one more example. Ketonic group on alpha position and a carboxylic acid. Now if you treat it with NaBH4, only this ketonic group will be reduced and the remaining groups will remain as it is. There will be no effect on the aromaticity of this benzene ring and no effect on the carboxylic acid. Benzoyl propanoic acid will get converted into hydroxy phenyl butyric acid. Let's take another example. This on reacting with NaBH4 will give us one more carbon, OH. This will be the product. If you have alcoholic group itself, what will be the effect of NaBH4? There will be no reaction in this case. कोई reaction नहीं होगा. The distinguished reactions that are carried out by using sodium borohydride, the very first is reduction of docile hydrazones. Now what is docile hydrazone? This is basically the docile hydrazone group. This docile is actually this group. This is called docile. NH2 is hydrazine. So compound having this kind of group attached is comes into the category of docile hydrazone. Now docile hydrazones are generally prepared by condensation of aldehyde or ketones with para-toluene sulfonyl hydrazine. Basically, this is para-toluene sulfonyl hydrazine, and aldehyde or ketone is reacted with this para-toluene sulfonyl hydrazine and docile hydrazones are prepared. For example, if you have acetone and that reacts with this para-toluene sulfonyl hydrazine, then the docile hydrazone which is obtained will be CH3, C double bond N, NH and docile. So this will be the docile hydrazone prepared. This is a very simple reaction. Then this docile hydrazone is further treated with your NaBH4 and alkene is obtained. So this is the simplest reaction which can be carried out using docile hydrazone, but it is mainly used to remove the carbonyl groups from the ketosteroid. So the main purpose of this method is to remove carbonyl groups from ketosteroids. Otherwise, you can say aldehyde and ketone on treating with paratoluene sulfonyl hydrazine first and then later treating with sodium borohydride are converted to hydrocarbons. And particularly this reaction is used for the removal of carbonyl groups mainly from the ketosteroid. Let's see an example of a ketosteroid. This is our ketosteroid. Firstly, paratoluene sulfonyl hydrazine will react and it will form docile hydrazone. And this will be formed on treating with NaBH4, this ketonic oxygen, or you can say the hydrazine group will be completely removed. This will be product. The second thing that is reduced by NaBH4 is azide. Reduction of azides. So azide is this functional group. This is azide. Azide normally doesn't get reduced with sodium borohydride, but if we reflux azide with NaBH4, refluxing in isopropanol here is solvent, NaBH4 will act as a reducing agent, and this process will require refluxing. If refluxing is done, then the azides are converted into amines, RNH2. This reaction takes place. This is also used in the preparation of diborane. BF3 on reaction with sodium borohydride gives us diborane and NaF, sodium fluoride.